Since we're going to be talking in the next video about how to pack a packet or how to generate a RIP version 4 using the Struct module, and we're going to be talking about, or we're going to be using the network byte ordering, I need to talk to you about the byte ordering before talking about UDP. So the byte ordering is a very important um, technique or part that a hacker may be aware of. So as you can see here, unfortunately, not all computers store the bytes that comprise a multi-byte value in the same order, which means that's where Indianasis comes in place. So we distinguish two type of Indianasis. We've got the big Indian or little Indian. Okay, the big Indian, actually the bytes would be stored from left to right, and the little Indian byte would be stored from right to left. So the reason that's and if you just think about it, if a client that has, for example, a CPU Intel architecture, which has the default Indianasis as little Indian, and another CPU and another client has the default Indianasis as big Indian, and both computers or both clients, if they will actually go ahead and communicate with each other, it's gonna be a problem. It's gonna be the packet would be received in the other end in the reverse order. So that's why the internet protocols specify canonical byte ordering or order convention for data transmitted over the network, and that is called network byte order. The network byte order is big Indian, so bytes are stored from left to right. So let me illustrate or simplify things. So that's an example of a short int x, 0xAABB in hexadecimal. This value could be stored or represented in memory from left to right or from right to left. So for example, if big Indian is used, the values are stored from left to right, as you can see here. So 0xAA and 0xBB, okay? The little Indian would be stored in the reverse order, so from right to left, okay? So from right to left. Actually, or fortunately, Python provides us a module to deal with such data. Okay, the module is called Struct Module. The Struct Module has two major methods. The first one is packing, and the second one is unpack. The Struct Modules, as you can see here, returns a tuple format. So, for example, if you want to pack the Ethernet header, actually you are going to, if you got a packet and that packet is in the network byte order format, you are going to use the unpack method with the exclamation mark here, which indicates the network byte ordering, and the less than sign is stands for the little Indian, and the greater than sign stands for the big Indian. So you are going to take the first six strings as the destination address, and the next six strings are this as the source address, and the h as 2 byte of with integers. This is integers. So as you can see here, these are the characters or the characters formats. So C for strings of length 1, the B is in 1 byte integer, H is 2 byte integers, L is 4 byte integers, and S stands for strings. For example, for a given IP address, we are going to use 4S. So let me actually import the struct module and play with it. Okay, so let's use the struct.pack here. I am going to try to pack, for example, 1 byte, 1 byte, and the value is 5 or is 4. So if we do it as H, as you can see here, values are stored from right to left, okay, which is little Indian. So if we go ahead and from sys import bytes order, bytes order, or I don't remember. byte order, and we just call byte order, actually you will notice that our CPU in the default indianesis is little Indian, which is an Intel family. Okay, so we can actually go ahead and change this to big Indian using the greater than value, and as you can see here, it was from has been represented from right to left. Now it is presented from left to right. So you can actually make changes to the value here, or you can either call the network byte ordering, which is by default big Indian. So let me give you a real example. So if we go ahead and cut proc routes, or if we go ahead do an ls CPU, and as you can see here, the byte order is little Indian. Let me prove that. If we go to proc net route, um, actually, as you can see here, this is the gateway. This is the gateway stored in the network byte ordering, which is little Indian. So let me prove you that if we are going to import Python, to enter a Python interpreter and import the struct module, and I am going to import the socket module, and let me store the value here as v, okay, as v. And as you can see here, we can go ahead and do v.encode hex, or decode, I'm sorry, decode. And as you can see here, this is an IP address in the network byte ordering format. So if we go ahead and store it on the value is equal to a, we can actually go ahead and do socket.inet, which is going to convert an internet address from network byte order to address, and the value is a. So as you can see here, the value is 172.16.122.1. So if we go ahead and fire up a terminal here and do an ifconfig, actually this is my IP address, but in the reverse order. So you can actually store it in a list or in an L, and dot split. I am going to split it by dots. So now we've got we can get it actually reverse it, and L is as follows, and we can actually join actually the L. Okay, so as you can see here, this is the gateway IP address. Okay, so if we do routes -n, as you can see here, this is my gateway IP address. So that's how little Indian or byte ordering and network byte ordering format is used under Python.